solid uniform sphere. So the solid sphere means it is filled from inside. A solid uniform sphere is made of a metal of density rho s, so its density is rho s, and the radius r, so its radius is r.
Yeah.
Volume v, its volume is v. It falls vertically through a viscous liquid of density rho l. So it is falling in a liquid which has a density rho l. Three forces act on it. Its weight, that's correct. First force is its weight, a drag force d, and an upthrust u. So there will be an upthrust u, there will be an drag force d, right?
Yeah.
The magnitude of the upthrust is equal to the weight of the displaced liquid by the sphere. I think you know this, right? The magnitude of
Yeah.
the drag
Yeah.
force is given by this. This is, you know, the drag force, viscous force, drag force. Okay, no problem. Where v is the speed of the metal sphere and k is a constant. Very good. What is the terminal speed of the metal sphere as it falls through the liquid? So do you know what's the terminal speed is?
Forces is balanced.
Yeah, the terminal speed is means when equilibrium established, when equilibrium gets established, then what will be the speed, right? Isn't it?
Yeah.
So let
Yeah.
us try to solve this. We have to find the speed. Okay. So let's see. See, W is downward, upthrust is upward, and drag force is also upward. Let us find these force first. How we can find the W, that is the weight, that is the m times g. Now, how we can find the mass?
Yeah.
Mass is density into volume, right? Density of solid is rho s, so I should write rho s into v into g. Now, how the volume? Okay, volume is given directly v. Otherwise, we can write in terms of r as well, right? Please see the option.
Yeah.
I think I don't have to use r right now. Okay, r is used, but v is also used, right? So I think it's better to keep it in v
Yeah.
only. So this is the weight, that
Okay.
is the rho s v into g. Now think about the upthrust. What is the upthrust? Upthrust is, you know, the weight. Do you know what's upthrust? Upthrust is the weight of displaced liquid.
Yeah.
Upthrust is the weight of displaced
Yeah.
liquid. It is the weight of displaced liquid. So the weight should be mass. Which
Yeah.
mass? Mass of displaced liquid. Mass of displaced liquid into g will give you the upthrust. And how the mass of displaced liquid we can
Yeah.
find? You know, mass is equals to density into volume. So density of liquid, you know what?
Well.
Density of liquid is equals to mass upon volume. So mass is what? Mass is density of liquid into volume. Is it okay? Now please see. Please see.
Yeah.
We are going to find weight of displaced liquid, right? So density should be of the liquid, correct?
Hmm.
Now which volume I need?
Yeah.
I need that volume which is displaced. And now suppose you are getting my point. Which volume we need? The volume which is
Yeah.
displaced by the ball. And if a metal ball, we see it's a metal ball, it's a solid sphere, so it is not hollow, so it will not
Yeah.
float, it will be completely immersed, right? So when it will go inside the
Yeah.
water or the liquid, the volume of this ball, right, the volume of water get displaced will be equals to the volume of this sphere completely, because this will go completely
Yeah.
inside the water. So right now I have to write the volume of a sphere here again. So it should be v, as it is given that its the volume is v, and it should be g. Is it okay? So this is the weight of displaced
Yeah.
liquid, that is the upthrust. Now what's the, you know, drag force is? So according to this drag force, it is krv. So it is k
Yeah.
times r times v. What is the v here? Where v is the speed of the metal sphere and k is the constant. And what is the r? R is the radius. Okay, so r is the radius.
Yeah.
Okay, see there is a one, you know, we have to take care the volume v and this v. This is the speed and that is the volume. So in place of this, you know, drag force, in place of simple v, now I will write some, you know, curved v like this, so that we should not get confused,
Okay.
right? So during the equilibrium, what will happen? During the equilibrium, the upthrust, you can say the upward force will be equals to the downward force, isn't it? So the upward
Yeah.
force and downward force should be balanced. So it is kr V plus rho L, this volume, into G should be equals to rho S V into
Yeah.
G. So from here we have to find the V, that is the velocity. So it should be Kr is equals to, no, rho S V G minus rho L V G.
Yeah.
So R is equals to, we can take common, V into G Kr V. Vg, that is the rho S minus rho L. Is it okay? It's not
Yeah.
R, it's KRV. So from here we have to find V. So it should be V times G. It should be Vg rho S
Yeah.
minus rho L upon KR. That should be the answer. Let us see. Vg.
Yeah.
Is there any option? I think this
Last
one.
option.
No, no, G1. G option, I think.
Oh, G. G.
I
Yeah.
think G. You may check the answer as well. So this should be our answer. This G.